Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 3.3, Problem 6. This is problem number 6 from Section 3.3. It says, Crazy Jasper's Appliance Emporium is having a one-day tent sale blowout on washers and dryers. Each washer requires 2 hours to unpack and set up. Each dryer requires 1 hour to unpack and set up. The tent space is limited to a total of 50 appliances. The budget for the store allows only 80 hours of employee time for unpacking and setup time. Each washer has a profit of $210. Each dryer has a profit of $185. How many of each should Jasper have his employees set up out in the tent in order to get the maximum profit? So there are 4 steps in order to just set up the problem, and then 4 more steps to do the problem. So in order to set it up, step 1 is identify the variables. And the variables are the 2 things being dealt with, and in this problem, it's washers and dryers. Those are the 2 things you're dealing with. Washers are mentioned first. I'm going to make those x. So we'll say x equals washers, y equals dryers. So that's step 1, identify the variables. Step 2 is write out the object function. So to do that, typically you want to look for information usually about profit, not always, and it's usually near the end. Again, not always, but this problem is fairly typical near the end of the problem. It says each washer has a profit of $210 and each dryer has a profit of $185. So that's going to give us our object function. So I'm going to write maximize z equals, so the washers are represented by x, and each washer has a profit of $210. So we're going to maximize z equals 210x plus, and the dryers, which are represented by y, have a profit of $185. So it's plus 185y. So step 2, write out the object function, gives us maximize z equals 210x plus 185y. Step 3 is set up the constraints, and now that's where most of the work is. So for the constraints, I'm going to write subject to, and we have a constraint of how much time there is to set it up. There's 80 hours. In addition to that, what you need to notice is the problem says the tent space is limited to a total of 50 appliances. That's a constraint. So the number of washers plus the number of dryers added together cannot total more than 50, because that's the amount of room you have in the tent. So my first constraint is going to be x, the number of washers, plus y, the number of dryers, must be less than or equal to 50. Because that's how much space there is in the tent. And as usual, I like to label these, so I'll just put space. Now, the other constraint will come from the fact that there is a total of 80 hours of employee time to unpack and set up these appliances. A total of 80 hours to unpack and set up the appliances. So there's going to be a separate constraint, 80, and we're going to have the same inequality symbol, less than or equal to, because 80 is the most that you can use. You can use all 80 or a little less. You can't use 82, you just don't have it. Now, as I read through the problem again, it says near the beginning here, each washer requires 2 hours to unpack and set up. And again, remember the washers are x. And each dryer requires 1 hour to set up and unpack. And the dryers are y. So the washers, which are x, require 2 hours, and the dryers, which are y, require 1 hour. And I'll label this too. I'll put unpack and setup. You don't have to write that much, but. And then that's step 3. I've set up my constraints. Step 4 is for each variable used in the problem, you must specifically mention that it is greater than or equal to 0. So the number of washers you put out in the tent can be as small as 0 or bigger. The number of dryers you set up in the tent has to be 0 or bigger. You cannot set up a negative number of washers. That's just, it doesn't even make sense. So you have to include these two. So that's the problem set up, all 4 steps. Step 1, identify your variable. Step 2, write out the object function. Step 3, set up the constraints. Step 4, mention that each variable must be greater than or equal to 0. Now we solve the problem. That has 4 more steps. So first, we're going to graph the feasible region. Then next, the second step is label the corner points. The third step is fill in that chart. And the last step is state your solution. So now to graph the feasible region, I am going to graph the 2 constraints that I have in this problem. The first one being x plus y is less than or equal to 50. So I'm going to graph that constraint in red, the less than or equal to 50. So I'm going to pretend it's x plus y equals 50 and find 2 points with x and y values that would make that equation true. So if I pretend that I have equals 50 and I zero out the x, then I simply have y equals 50. And then to get a second point, I can zero the y variable, and I would see that I would have the equation x equals 50. Now, and I'm going to graph the first one I do in red. The second one I graph for the available time for unpacking and setting up. I'll do in a different color. I'm going to go with green. So same process. I have 2x plus 1y is less than or equal to 80. Start off by pretending it's 2x plus 1y equals 80. And I'm going to make a little xy chart and fill that in. Now if I zero the x, the 2 times x just zeroes out, and I would be left with y equals 80. And if I zero the y to pick up a second point, I would have the equation 2x equals 80. And if 2 times x is 80, the x must be 40. Now, in order to graph my 2 constraints, I'm going to have to deal with values as large as 80 for the y and 50 for the x. That's certainly too big to do one at a time on my number scale. You could if you have a lot of time to spend, but 10 at a time is what I'm going to choose. You can choose anything as long as you label it. So I have a graph that I started here, and I didn't label the x and y axis, so I'm going to label them in intervals of 10. So the y can be labeled 10, 20, 30, 40, 50, 60, 70, 80. That's more than enough, but I'll run it to 100. That's a natural spot to stop. And the x's, I can run 10 at a time also. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Again, more than enough, but that's fine. And just to remind you, the x-axis and y-axis do not have to be labeled on the same interval. You can do whatever's convenient as long as you label them. If your biggest x is, say, 7, you can run the x's one at a time. And if your biggest y is, say, 32, you could run the y's maybe 5 at a time. As long as you label it, it's OK. Now, on the graph that I set up, let me graph the constraint for space. The x plus y is less than or equal to 50. I started that one in red, so I'm going to continue in red. Now, one of the points that I need to put on my graph is over 0 up 50. So I'm going to put a red dot at the point over 0 up 50. I'm going to put a second red dot at the point over 50 up 0. Now I have 2 red dots. And I'm going to connect those 2 red dots with a red line. And now that I have the red line connected, I have to decide whether I should shade above that line or below. So in order to determine that, choose a test point that's not on the line. Use 0, 0 if you can, and 0, 0 is not on the line. And plug in the x and y values of your test point into the constraint. So x plus y is less than or equal to 50 becomes 0 is less than or equal to 50. And that's true. 0 is less than 50. So the test point came from the underneath side of my line, gave me a true result when I put it in the line. So my test point is in the shaded region, which means I shade below the line. Now, the next constraint for the unpacking and setup time I did in green. So I have 2x plus 1y is less than or equal to 80. I started that one in green. So to put that on my graph, I'm going to put one point on the graph that is over 0 up 80. So I'll find the point that is over 0 up 80 and make a green dot. I'll put a second green dot at over 40 up 0. And I find that point on my graph and put a dot at over 40 up 0. I have 2 green dots on my graph. I will now connect them with a green line. Next, I have to determine if I should shade above the green line or below it. Same process. I'm going to use the test point that I like, 0, 0, which I get to use because it's not on my line that I'm graphing. And I'm going to plug in the x and y coordinate of my test point into the constraint that I'm graphing. So the 2x plus 1y is less than or equal to 80. When I put in 0 for x and 0 for y, I get 0 is less than or equal to 80, which is true. So, like before, the test point came from the underneath side of my line, gave me a true result when I put it into the constraint. So the test point is in the shaded region, which means the underneath side is the shaded region. And I won't even continue to shade above the red line, because I know I have to satisfy all my constraints for my feasible region. So now, the x greater than or equal to 0, which is the next constraint, just tells me that I cannot have any points in my feasible region with a negative x coordinate. And that says I have to stay on the right side of my y-axis. I cannot come over to the region of the graph that has points with a negative x coordinate. And the y greater than or equal to 0, the last constraint, tells me I have to stay above the x-axis, because if I get below the x-axis, I would have points with a negative y coordinate, which this says I cannot do. And now the area that satisfies all the constraints simultaneously is my feasible region, which I will shade in heavily. I'll do it in red. It is a bounded feasible region. And when you shade in the area, there's some extra triangles that you don't want to shade too much. You have to be shading the area that satisfies all of your constraints simultaneously. So I don't want to shade in the upper triangle formed in my graph or this lower right triangle. So that's the first part of the process of finding the solution, is graphing my feasible region. The next part of the process is to label the corner points. So one corner point is over 0 up 50. Another corner point is 0, 0. Another corner point is over 40 up 0. And now there's another corner point that's not right along the x-axis or y-axis. From my graph, it looks like it's over 30 up 20, but the way you need to do that to really verify it is solve the equations for the two lines that intersect with each other, solve them simultaneously. I should have enough room right up here. So one of my two is the green line, which I have written by 2x plus 1y, and I'm going to put equals 80. So I have 2x plus 1y equals 80. And then the green one intersects with the red line, which is represented by x plus y, and I'm going to put equals 50. And just to make it match, I'll make it 1x plus 1y equals 50. Now, I can either cancel the x's or the y's. Either one should work. Either one will give me the same answer in the end. But the y, I think, is a little easier. So I will keep the top equation totally as it is. So it's just going to stay 2x plus 1y equals 80. And now the equation that was underneath, everything's going to get multiplied times a negative 1, because the positive 1y that I had initially, I want to convert to a negative 1y. So when I multiply the bottom equation times negative 1, I'm going to have 1x times negative 1 is negative 1x. 1y times negative 1 is negative 1y. And don't forget to do the 50 times negative 1 is negative 50. Now, if I combine the two new equations that I've made, positive 2x, negative 1x is just going to give me an x or 1x. Positive 1y, negative 1y will cancel. Positive 80 and negative 50 is 30. X equals 30. So the x coordinate of the point where the red line and the green line intersect with each other, that has an x coordinate of 30. Now, for the y coordinate, I can take my x as 30, go back to either of the original equations to find the y. Either one should work. The bottom one I think is a little bit easier. They'll both give you the same answer, but if I take the bottom one, x plus y equals 50, and now that I know x is 30, 30 plus something equals 50, well, the y has to be 20. So the graph was good enough. I could have read this one off the graph. That's not always the case. Now that I have the corner points of my feasible region labeled, the next step is to set up that chart and plug each corner point into my object function. So the first column of my chart is going to be for corner points, and I will label it. The middle column I make the widest. That's for the object function, which for this particular problem is z equals 210x plus 185y. And the last column is for output. And I have 4 corner points, so I will need 4 rows in my chart. One corner point is 0, 50. The next corner point is 30, 20. The next corner point is 40, 0. And the last corner point is 0, 0. Now what I'm going to do is plug the coordinates of each one of those corner points into the object function and see what type of output I get. So the first corner point, 0, 50, means x is 0, y is 50. So the 210x becomes 210 times 0, plus 185y becomes 185 times 50. So 210 times 0 is 0. 185 times 50, I think, is 9,250. Let me check that with the calculator. 185 times 50 is 9,250. And now if I add 0 plus 9,250, I get a result of 9,250. And what that result means is Jasper will have a profit of $9,250 by setting up 0 washers and 50 dryers. The next corner point, 30, 20, I will plug into my object function. So in the object function, the 210x becomes 210 times 30, and the 185 times y becomes 185 times 20. So 210 times 30 will be 6,300. And the 185 times 20 should be 3,700. I'll check that just to make sure. It is. And then if you add 6,300 plus 3,700, that's 10,000. That's a little bit better. So Jasper will have a profit of $10,000 by setting up 30 washers and 20 dryers. The next corner point, 40, 0, is 210x becomes 210 times 40, and 185 times y becomes 185 times 0. 210 times 40 will be 8400. 185 times 0 is just 0. So you have 8,400 plus 0 is 8,400. That's not quite as good. So Jasper will have a profit of $8,400 by setting up 40 washers and no dryers. Now remember, there's room for 50. So what's happened with this is he's used up all his employee time of 80 available hours to set up the 40 washers. So even though there's 10 empty spots, he has no more employee time to set up anything else. And then the 0, 0, of course, is going to give me an output of 0. So the last corner point is 0, 0. When I plug that in, the 210x becomes 210 times 0. 185y becomes 185 times 0. So I'm going to have 0 plus 0, which adds up to 0. So Jasper will have a profit of $0 if he doesn't set up any appliances, which of course makes sense. Now, the final step, state your solution. The possible answers we can get are a profit of $9,250, a profit of $10,000, a profit of $8,400, or a profit of 0. Well, the best one is the profit of $10,000. So at the end, where we should state our solution, we will say maximum profit of $10,000 by setting up $30 washers and 20 dryers. And that's the answer.